Hello and welcome, people of the internet and programming enthusiasts. Today we are going to be discussing Python's with statement. We'll also be going into how context managers work as well. Now, you may be familiar with a classic scenario. You want to open a file and write to it, so you use the with statement. Something like this. A simple bit of code that opens the file and writes to it. At least I hope you are doing it this way and not implementing your own fucking logic for reading text files, but in any case, Python handles almost everything that happens in between opening and closing the file. So, how does it work exactly? This is done using what is known as a context manager. A context manager is any object in Python that sets something up, runs some code arbitrarily, and then tears it down as well. Later in the video, I'll show an interesting and practical example on how a context manager can be used. A context manager will usually consist of two special dunder or double underscore methods. Enter, which is the setup logic for your context manager, and exit, which handles teardown logic. If we were to create our own context manager, we could do it as a simple class making use of those two dunder methods. So just create a class and we'll call it myContext with an enter dunder method. And we'll just add a print statement to show we have entered the context manager. We will do the same with the exit method and add a print statement as well. The exit method takes some additional arguments, but we will get to that a bit later. We can then utilize this context manager with a regular with statement and add another print statement just to see what's going on. Now, when we run this, notice how the print statements inside the enter and exit methods were called as expected. It's important to also know that exit will always be guaranteed to run regardless of what happens or goes wrong within the context manager. The arguments that the exit method takes are specific to whenever an exception occurs and kind of self-explanatory. This would be the type of exception raised, the actual exception instance, and a traceback of where the exception occurred. If there's no exception, all of these arguments will just be none. Let's just show a simple exception inside this with block using the base exception class. Now let's print out the exception type and value inside the exit method of our myContext class. We can now see that we entered the context manager, encountered an exception, and displayed the exception type and the message raised with that exception. You can try this out with value error if you wanted, but this is extremely basic and isn't a good representation of a context manager at all. So let's try something a little bit more practical with some real use case. Let's say you want to create a database connection that handles connections, cursors, rollbacks, commits, and closing the database connection. You could do it the following way. Let's use SQLite 3 for this example. So first we import SQLite 3, then we create our database connection and establish a database cursor. Using this connection, we will use a try-catch block for our rollback and to close the connection. Now, let's say we have to create a table called users, and we have to insert a new user as a row into that table. We use our cursor to execute these SQL statements. And then commit them once it is done. Now we roll back our connection on exception. And then close the connection using a finally block. This works, but it can always be better. Don't be a degenerate and strive for mediocrity. This approach requires that we manually open a connection, commit or roll back any changes, and then close the connection. A context manager solves the problem of having to do this manually. Let's rewrite this approach with a context manager. We'll create a simple class to represent our database connection. This class will have a constructor that receives our database name as an instance argument. Now we create our enter and exit methods. The enter method is going to create the connection and provide a cursor for interacting with the database. The exit method is going to handle the rollback, commits, and closing the database connection. We can just add a little if statement to check if there is an exception and roll back, else we commit and finally close the connection. Now, using the context manager is as simple as calling our class using the with statement, and we no longer have to concern ourselves with handling basic database shit. We can also just copy and paste the previous SQL statements and replace the name. Now you may be saying, but this is more code than the other solution, blah, blah, blah. But what happens if we need to access that database in a different part of the code? Are we going to rewrite that same code over and over? Absolutely fucking not. And yes, this is more code, but what if I told you that we can simplify this even further? Of course, writing your own context manager sucks. if you have to be the one responsible for the enter and exit methods, which is why Python has a built-in module known as contextlib, which helps to create our own context managers, and we don't need to resort to a class. Contextlib provides us with a nice method decorator that turns a simple generator function into a context manager. I'll be doing a video on generator functions as well at some point, so keep an eye out for that. Let's see how that generator function would look. We'll write a regular function and use that method decorator we imported. Method decorators always have the @ symbol at the start, so remember that. Let's just call it OpenDB, and we can say it takes an argument of database name. We create our connection and establish a cursor. We will also include our connection, cursor, and rollback code with it in a little try-catch block. We want to yield a cursor and commit any changes, and if there is an exception, we can just print the exception and roll back the transaction. Then finally, we can close the connection. Now we can write our with statement. We can call the OpenDB function, which gives us access to the database cursor, which can then use to execute the SQL. So just copy paste that again, but change the name being inserted. The yield keyword in this specific generator function gives control to the with block to access and interact with whatever was yielded. In this case, it is the database cursor. Just try to think of it this way. Everything before the yield keyword can be seen as the enter method, and everything after the yield keyword can be seen as the exit method. We've now just turned a database connection into a simple little utility that can be used anywhere, all thanks to context managers. So yeah, that's about it. Thank you very much for watching. Please leave a like and subscribe if you enjoyed the video. I will leave a GitHub link in the description for the code used in this video if you'd like to have a look. Until next time, goodbye.